February 2009, the final heavy stamping presses in Corona, California, were dismantled and sold for scrap. The deafening roar of millions of micro-engines that once defined an era was permanently silenced. For over half a century, this wasn't just a toy company, it was the entry point to American aerospace. At its peak, it operated with the precision of a military contractor, churning out millions of PT-19 airplanes and filling the suburbs with the unmistakable, high-pitched scream of the Hanaro 49 Baby B engine. They transformed ordinary garages into miniature engineering labs, selling over 50 million engines worldwide. Today, the nitro fuel has dried up. The intricately machined aluminum has been replaced by cheap disposable plastics. The sprawling factory floors are empty, and the brand is nothing more than a ghost, a forgotten trademark traded among corporate conglomerates. How does an empire that taught generations of aerospace engineers the laws of physics simply vanish? It wasn't just the rise of video games or noise ordinances. It was a slow, agonizing suffocation by corporate spreadsheets and a desperate race to the bottom. This is the story of Cox Models, a journey from a visionary machinist's garage in California to the cold boardrooms of Wall Street. What happened here is more than the death of a toy company. It is the death of an era where children built their world with their bare hands. The year was 1945. The Second World War had just drawn to a close, and a victorious United States was entering an era of unprecedented prosperity and transformation. Millions of soldiers were returning home, trading their military fatigues for factory aprons and suburban mortgages. In the sun-drenched expanse of Southern California, a restless energy permeated the air. It was a time when the American dream seemed tangible, waiting to be assembled in backyard sheds and dusty garages. Among those driven by this post-war optimism was Leroy Cox, a machinist with an uncompromising eye for precision and a quiet, relentless ambition. Cox did not start out with visions of aerospace dominance or global manufacturing empires. His beginnings were remarkably humble. Operating out of his modest garage in Santa Ana, California, he founded the Cox Manufacturing Company. Initially, his catalog consisted of simple, unpowered wooden pull toys, pop guns, and little wooden wagons designed for children whose fathers had just returned from the battlefields of Europe and the Pacific. But Leroy Cox was a man who understood the shifting tides of American culture. The children of the late 1940s were growing up in the shadow of the atomic age and the dawn of jet propulsion. They had watched B-29 superfortresses streak across the sky and read comic books filled with rockets and mechanical marvels. Wooden wagons were quickly losing their appeal. The youth of America did not just want to pretend, they wanted to participate. They craved machines that felt real, machines that smelled of oil and vibrated with actual mechanical life. Recognizing this hunger, Cox pivoted. He looked toward the nascent hobby of model aviation in tether cars. At the time, miniature internal combustion engines existed, but they were not toys. They were temperamental, highly complex, and prohibitively expensive pieces of specialized equipment, reserved almost exclusively for affluent adults with advanced engineering knowledge. These early engines required a profound understanding of mechanics just to get them started, and they broke down with maddening regularity. Leroy Cox saw a gaping void in the market, but filling it presented an almost insurmountable engineering challenge. To capture the imagination of the American boy, he needed to create an engine that defied the established rules of manufacturing. It had to be light enough to fly, powerful enough to thrill, robust enough to survive being repeatedly crashed into suburban pavements, and, most crucially, cheap enough to be bought with allowance money or gifted on a middle-class Christmas morning. It was a paradox. Precision engineering and mass-market affordability were historically mutually exclusive. If you wanted precision, you paid a premium. If you wanted cheap, you accepted sloppy tolerances and frequent failures. Cox refused to accept this dichotomy. Drawing upon his deep machinist background, he began experimenting with aluminum alloys and radically simplified engine designs. The tension in that small California garage was palpable. Cox spent countless hours at his lathe, shaving fractions of a millimeter off pistons and cylinders. He understood that in a miniature engine, the margin for error was non-existent. A gap of a thousandth of an inch could mean the difference between an engine that roared to life and one that remained a silent, useless lump of metal. He was not merely designing a toy, he was attempting to scale down the ferocious power of an internal combustion engine to fit in the palm of a child's hand, without sacrificing reliability. His early attempts with tether cars, specifically a model powered by a competitor's engine, proved frustrating. The engines he sourced from outside suppliers were unreliable, tarnishing the reputation of his meticulously crafted miniature cars. It became crystal clear to Cox that if he wanted the job done to his exacting standards, he had to build the heartbeat of the machine himself. This realization marked the true genesis of the Cox manufacturing philosophy. It was a commitment to vertical integration and absolute control over the manufacturing process, long before such terms became corporate buzzwords. Leroy Cox decided that his company would not just assemble toys, it would master the alchemy of metallurgy, thermodynamics, and mass production. The transition from wood to metal, from static toys to explosive, nitro-fueled power plants was underway. The sawdust in the garage was swept away, replaced by the sharp metallic scent of cutting fluid and the deafening high-pitched whine of prototype engines being tested on the workbench. Leroy Cox was no longer just a toy maker. He was laying the foundation for a mechanical revolution, forging a path that would soon transform millions of ordinary American driveways into test tracks and launch pads. The spark had been ignited, but the true explosion was yet to come. The breakthrough that would cement Leroy Cox's legacy arrived in 1956. It was a masterpiece of miniature engineering known simply as the Bay B-049. This tiny internal combustion engine, displacing a mere 49 cubic inches, was unlike anything the market had ever seen. It was not a fragile plaything. It was a rugged, high-revving power plant capable of screaming at 15,000 revolutions per minute. Machined from solid extruded aluminum bar stock, the Bay B utilized a remarkably efficient reed valve induction system. This design choice stripped away the terrifying complexity that had previously plagued miniature engines. It was astonishingly reliable and, more importantly, it was manageable. For the first time, a 10-year-old boy could flip a tiny plastic propeller and successfully coax a real engine to life. But Cox was a visionary, not just a machinist. He understood that a standalone engine, no matter how brilliantly engineered, was only half of the equation. To truly ignite a cultural phenomenon, he needed to provide a vessel for that power. Moving away from the wooden toys of his past, Cox fully embraced the post-war plastics boom. He combined the furious energy of the Bay B engine with a durable, impact-resistant plastic airframe to create the Cox PT-19 flight trainer. Modeled after the primary training aircraft used by the United States Army Air Forces, the Cox PT-19 was a revolution in retail packaging. It was a ready-to-fly control line airplane. There were no complex balsa wood frameworks to glue together, no delicate tissue paper to stretch over wings. A child simply opened the box, attached the Dacron control lines, filled the small tank with a specialized blend of nitromethane and castor oil, and spun the prop. The resulting explosion of popularity was unprecedented. The PT-19 did not just sell, it vanished from store shelves. For less than $10, the American middle class could purchase the visceral thrill of aviation. The moment that tiny engine roared to life, violently vibrating the plastic fuselage before launching into a dizzying 50-mile-per-hour circle, it captivated the imagination of an entire generation. Almost overnight, the sensory landscape of the American suburb was altered. The sweet, pungent exhaust of burnt castor oil drifted over backyard fences. The distinctive, high-pitched shriek of the Leroy 49 engine became the defining soundtrack of Saturday afternoons. From sun-baked schoolyards in California to grassy parks in the Midwest, millions of children were looking up, feeling the physical pull of a mechanized tether and learning the raw principles of thrust and aerodynamics. However, this massive cultural triumph immediately spawned a daunting industrial crisis. The demand for the PT-19 and the standalone Bay B engines was staggering, far exceeding the wildest projections. The small workshops were operating around the clock, yet they were helplessly backlogged. Retailers across the country, and soon across the Atlantic and Europe, were demanding inventory that simply did not exist. Leroy Cox had successfully captured lightning in a bottle. He had created a product that required the exacting, microscopic tolerances of an aerospace contractor, yet needed to be mass-produced in the millions and sold at the price of a standard toy. It was an engineering paradox that threatened to crush the company under its own weight. To survive the very success he had engineered, Cox realized that the era of the workshop was over. He needed to build a true industrial behemoth. The solution to this unprecedented supply crisis was not to seek cheaper labor or to outsource production, but to double down on American manufacturing. In the early 1960s, Leroy Cox constructed a sprawling, state-of-the-art facility in Santa Ana, California. This compound was unlike any toy factory on Earth. Walking onto the main production floor was akin to stepping into a defense contractor's advanced machine shop. It was an industrial cathedral dedicated to the art of miniaturization. Rows upon rows of massive, imported automatic screw machines operated continuously, their rhythmic thudding echoing through the cavernous space as they chewed through literal tons of extruded aluminum bar stock. They churned out millions of microscopic engine cylinders, pistons, and intricate crankcases with ruthless mechanical efficiency. To maintain the impossibly tight tolerances required for the .049 engines to run reliably, often within 1/10,000th of an inch, a fraction of a human hair, Cox employed an army of highly skilled, well-compensated American machinists and engineers. The absolute commitment to perfection was most evident in the factory's legendary testing division. Unlike other mass-market toy companies that relied on random batch sampling to check for defects, Leroy Cox instituted a mandate that bordered on the obsessive. Every single engine had to be test-fired before it was cleared for packaging. The testing floor was an environment of pure auditory intensity. It was a continuous, screaming chorus of dozens of miniature engines being simultaneously spun up to their 15,000 RPM redlines by technicians working inside specialized booths. The air was thick with the sweet, unmistakable scent of burnt castor oil. If an engine hesitated, sputtered, or failed to hold a steady needle valve setting, it was immediately pulled from the line and sent back for recalibration. This uncompromising quality control forged an unbreakable bond of trust with the consumer. When a family purchased a Cox product, they were buying a guaranteed, fully functional piece of machinery. This era marked the absolute zenith of the Cox Models empire. Throughout the 1960s, the company expanded its dominance far beyond the initial PT-19 trainer. They introduced highly detailed scale models of P-40 Warhawks, Ju-87 Stuka dive bombers, and sleek tethered gas-powered race cars like the legendary Chaparral 2E. Independent hobby shops and major department stores across the globe dedicated vast prime retail spaces exclusively to the brand. Entire walls lined with brightly colored boxes, blister packs of replacement glow plugs, and the iconic rectangular metal cans of Cox Superpower nitro fuel. Cox Models was no longer just a business, it was a cultural institution. They were selling millions of units annually, quietly inspiring a generation of future pilots, mechanics, and aerospace engineers who were learning the visceral laws of thermodynamics and aerodynamics in their own backyards. The company had achieved the ultimate manufacturing dream, producing high-precision, complex machinery on a massive scale at a price point accessible to the working class. Yet the very architecture of this triumph harbored a fatal rigidity. The Santa Ana factory was a magnificent, highly specialized beast, but it was a beast that required massive amounts of capital and specific macroeconomic conditions to survive. It demanded cheap domestic aluminum, affordable American labor, and a consumer base deeply enamored with mechanical grit. Cox had built a flawless, unstoppable machine, perfectly calibrated for the world of 1965. But as the decade drew to a close, the global economy began to shift, and the heavy, expensive gears of the Cox empire were not designed to pivot. As the 1960s bled into the 1970s, Cox Models appeared invincible to the outside observer. The brand was an unshakable pillar of American boyhood, as ubiquitous as baseball gloves and bicycles. Retail catalogs dedicated glossy, full-color pages to their expanding fleet of aircraft, cars, and rocketry. The sprawling Santa Ana facility was operating at a blistering pace, its loading docks a constant blur of activity as tractor-trailers hauled away millions of precisely engineered dreams in brightly colored cardboard boxes. On paper, it was the zenith of Leroy Cox's visionary empire. But beneath the deafening hum of the automatic screw machines and the sweet scent of nitro fuel, deep tectonic fractures were beginning to form. The very architecture of Cox's success was quietly morphing into an inescapable trap. The first unseen enemy was macroeconomic. The post-World War II economic boom, which had provided a seemingly endless supply of cheap raw materials and immense middle-class purchasing power, was sputtering to a halt. The early 1970s brought the ominous clouds of inflation and global instability. For a company whose entire identity relied on the mass consumption of refined metals, this shift was catastrophic. To maintain the microscopic tolerances of a screaming 15,000 RPM micro-engine, Cox could not use inferior metals. The Babe B and its successors required high-grade, extruded aluminum bar stock. They required specialized alloys for the pistons and cylinders to manage the intense thermal expansion and friction of internal combustion. As global commodities markets convulsed, the price of these raw materials began a relentless upward climb. Suddenly, the literal building blocks of the Cox empire were becoming prohibitively expensive. Simultaneously, the company was colliding with the harsh reality of market saturation. For nearly 15 years, Cox had been selling engines by the millions. But there is a mathematical limit to how many control line airplanes a single suburban neighborhood can absorb. By the early 70s, almost every child who wanted a PT-19 already owned one, or had inherited a battered, grass-stained model from an older sibling. Growth was no longer explosive, it was plateauing. The company had successfully transitioned to a razor and blades model, selling the airplanes at a narrow margin to ensure a steady, lucrative stream of revenue from the consumable Cox Superpower nitro fuel, replacement glow plugs, and spare propellers. However, this model demanded an enormous, constant volume of use to sustain the massive overhead of the Santa Ana factory. Herein lay the paradox that kept Leroy Cox awake at night, the golden cage. He had built a magnificent, state-of-the-art manufacturing behemoth perfectly calibrated for the world of 1965. The factory was inflexible by design. It was engineered to do one thing: produce the finest miniature internal combustion engines on Earth, and to do it with absolute, uncompromising perfection. But as manufacturing costs surged and retail demand flattened, the profit margins on each engine began to evaporate. The traditional corporate response to such a squeeze would be to aggressively cut costs, to widen the manufacturing tolerances, use cheaper, softer metals, or outsource the labor to overseas factories with lower wages. For Leroy Cox, these options were not just bad business. They were a betrayal of his fundamental ethos. He was a master machinist first and a businessman second. To loosen the tolerances meant the engines would run hot, sputter, and die. It meant breaking the unspoken promise he had made to millions of children, that a Cox engine would always start and it would always scream. If he compromised the mechanical integrity of his product, he would destroy the soul of the brand. Yet if he stubbornly maintained his fanatical quality control, while costs skyrocketed, the company would eventually bleed to death. The immense pressure of managing this colossal, inflexible machine began to take a heavy toll. Cox found himself increasingly detached from the drafting tables and the testing booths, the places he loved most. Instead, his days were consumed by labor union negotiations, supply chain logistics, and agonizing meetings over shrinking margins. The joyful, experimental atmosphere of the post-war garage had been entirely swallowed by the cold, unforgiving demands of industrial-scale capitalism. The walls of the Santa Ana factory, once a testament to American ingenuity, now felt like a fortress under siege. Leroy Cox realized that his company was too big to pivot, too proud to cheapen its product, and too exposed to the shifting economic winds. The era of the visionary inventor was ending. To survive the brutal economic climate of the 1970s, the company would require a massive infusion of capital and a ruthless restructuring of its financial DNA. It was a realization that would force the founder to make the most agonizing decision of his life. The machine he had built was perfect, but it could no longer survive in the wild. It needed to be sold. By 1969, the relentless pressure of keeping the golden cage afloat had worn Leroy Cox down. He was a man who found peace in the predictable, mathematical certainty of a micrometer, not in the volatile, ruthless arena of corporate finance. As macroeconomic headwinds intensified and the sheer scale of the Santa Ana operation became increasingly burdensome to manage alone, the founding father of miniature aviation made the agonizing decision to step away. After nearly a quarter century of building a global empire from a dusty garage, Leroy Cox sold his life's work. The buyer was Leisure Dynamics, a rising corporate conglomerate with an aggressive appetite for acquiring successful recreational brands. At the time of the sale, it seemed like a logical, even necessary transition. Leisure Dynamics possessed the massive capital reserves required to insulate Cox Models from the shockwaves of fluctuating aluminum prices, and the marketing muscle to push the brand into new, untapped international territories. But beneath the celebratory press releases, the acquisition marked a fundamental, irreversible mutation of the company's core DNA. The transfer of power was not merely a change in ownership, it was a violent collision of two deeply incompatible philosophies. For Leroy Cox and his veteran machinists, the company existed to build perfect, miniature mechanical systems. The revenue was simply the natural byproduct of achieving engineering excellence. For the newly installed executives from Leisure Dynamics, however, the screaming .49 engines were just widgets on a spreadsheet. In their eyes, the company did not exist to inspire future aviators. It existed solely to generate predictable quarterly profits for shareholders. When the new management team first walked the floors of the Santa Ana facility, they did not see a magnificent cathedral of American manufacturing. Looking down from the catwalks at the rows of massive automatic screw machines and the frantic, deafening testing booths, they saw only bloated overhead. Where the original floor managers saw a vital, meticulous quality control process, the very system that guaranteed every Cox engine would start on the first flip, the Leisure Dynamics accountants saw a terrifying waste of man-hours, raw materials, and nitro fuel. The cultural shift within the factory walls was swift and disorienting. The seasoned engineers who had spent decades alongside Cox, refining the Baby B to its absolute physical limits, suddenly found themselves answering to financial officers who had never operated a lathe or smelled burnt castor oil. The language of the company changed overnight. Hallway conversations shifted from impassioned debates over thermodynamics, metallurgical integrity, and reed valve performance to cold discussions about profit margins, aggressive cost-cutting initiatives, and labor optimization. This was the first critical breaking point for the brand. The new corporate overseers fundamentally misunderstood the nature of the machine they had purchased. They treated the unwavering loyalty of the Cox customer base as a permanent, bulletproof asset, an immutable law of retail nature. They failed to realize that this fierce loyalty was entirely tethered to the unyielding, expensive quality that Leroy Cox had stubbornly insisted upon. The board members of Leisure Dynamics were under immense pressure from Wall Street to show an immediate outsized return on their multi-million-dollar acquisition. They scoured the Santa Ana ledgers, hunting for any opportunity to trim the fat. The mandate handed down to the production floor was clear and merciless. Produce more units, but do it faster, and above all, do it cheaper. The golden era of building an engine to perfection and pricing it later was officially dead. A strict, aggressively low cost per unit was now dictated from a distant boardroom, and the legacy engineering department was ordered to cannibalize their own process to make the math work. To satisfy the relentless demand for higher margins, the newly installed management targeted the very heart of the Cox manufacturing philosophy, the raw materials and the microscopic tolerances. The premium, high-grade extruded aluminum that had long defined the durability of the .49 engine was quietly replaced with softer, less expensive alloys. The massive automatic screw machines on the Santa Ana production floor were recalibrated, pushed to run at higher speeds to increase the hourly yield. But in the unforgiving world of miniature internal combustion, speed without meticulous care equals catastrophic failure. The pistons and cylinders, once mated with zero clearance perfection, began rolling off the assembly line with tiny, almost imperceptible flaws. However, the most devastating blow was dealt to the company's legendary quality control division. For decades, Leroy Cox had steadfastly insisted that every single engine be test-fired before leaving the building. To Leisure Dynamics, the deafening, fuel-soaked testing room was nothing more than a financial black hole, an archaic practice that wasted expensive labor and thousands of gallons of nitro fuel on units that had already been fully assembled. The sweeping corporate directive came down without room for negotiation. The 100% test-fire mandate was immediately abolished. It was replaced with standard, random batch sampling. If a small handful of engines from a massive production run happened to start up, the accountants deemed the entire batch acceptable, and the boxes were shipped to retailers. The immediate financial results were exactly what Wall Street had demanded. By drastically reducing overhead, material costs, and labor hours, the quarterly profit margins temporarily soared. Leisure Dynamics executives patted themselves on the back, presenting the numbers as proof that they had successfully modernized a stubborn, antiquated manufacturing operation. But on the ground, in the driveways, schoolyards, and parks of suburban America, a silent tragedy was beginning to unfold. The fundamental, unwritten promise of a Cox model, that it would always start and scream with life, was broken. Children began opening their brightly colored PT-19 boxes on birthdays and Christmas mornings, only to experience crushing, frustrating disappointment. They would flip the tiny plastic propellers until their fingers were bruised, cut, and slick with castor oil, but the compromised engines would only offer a weak, asthmatic sputter, or worse, absolute silence. The veteran machinists who had remained at the Santa Ana plant watched this unfold in quiet despair. They knew exactly what was happening to the metal. The company was no longer selling precision machinery, it was selling the mere illusion of it, riding the coattails of a pristine reputation built by a man who had already left the building. Leisure Dynamics was aggressively extracting the accumulated brand equity of Cox Models and converting it into short-term dividends. They were blissfully unaware that by hollowing out the mechanical integrity of the product, they were destroying the very foundation of the empire. The golden era of American miniature aviation was definitively over. The cold, calculating era of the spreadsheet had officially taken control. But this new corporate machine was about to encounter an external enemy that no amount of financial restructuring could defeat. By the dawn of the 1980s, the American cultural landscape was undergoing a seismic, irreversible transformation. The post-war fascination with gears, grease, and mechanical propulsion was rapidly giving way to a new, glowing obsession: silicon, pixels, and the microprocessor. The very definition of what constituted a toy was shifting from the physical realm of the backyard to the virtual reality of the living room television set. Cox Models, a company whose entire identity was forged in the heat of internal combustion, found itself facing an alien, silent, and incredibly powerful enemy. The first wave of this digital invasion arrived in the form of home video game consoles. The Atari 2600 and, soon after, the Nintendo Entertainment System offered children an entirely new, deeply addictive dopamine loop. In the past, the thrill of play came from the physical labor of construction and operation, the meticulous tuning of a needle valve, the sharp pull of a starter spring, and the visceral reward of a screaming engine taking flight. Video games replaced that arduous process with instant gratification. With the simple push of a plastic button, a child could pilot a spaceship or race a high-speed car without ever leaving the couch, smelling like exhaust or wiping oil off their hands. But the threat to Cox Models was not confined merely to the television screen. The physical hobby market itself was evolving at a breakneck pace, leaving the nitro-fueled .049 engine looking increasingly like an antiquated relic. The 1980s witnessed the explosive rise of electric radio control, ERC vehicles. Japanese manufacturers like Tamiya and Kyosho began flooding the American market with highly engineered, battery-powered buggies like the Grasshopper and the Frog. These new electric models utilized rapidly advancing nickel-cadmium (NiCad) battery technology and efficient brushed electric motors. They offered a completely different user experience. Electric RC cars were quiet, impeccably clean, and remarkably user-friendly. A child simply plugged the battery into a wall charger, snapped it into the chassis, and pulled the trigger on a remote control. There was no highly flammable nitro fuel to spill on the garage floor, no precise carburetor adjustments required for varying weather conditions, and no frustrating starting rituals. By contrast, the experience of operating a Cox engine, especially the compromised, lower-quality units being churned out under corporate ownership, was becoming a chore that modern children were increasingly unwilling to endure. Starting a miniature internal combustion engine was an art form that required patience, physical exertion, and a tolerance for pain. Generations of modelers were intimately familiar with the Cox knuckle, the inevitable stinging cuts and bruises inflicted by a rapidly spinning, razor-sharp nylon propeller when an engine kicked back during starting. For a child of the 1960s, a bleeding finger was a rite of passage, a small price to pay to tame a mechanical beast. For a child of the 1980s, accustomed to the painless, plug-and-play nature of modern electronics, it was simply an unacceptable deterrent. Faced with this existential threat, the leadership of Cox Models, now being passed around between various corporate holding companies like a depreciating asset, suffered from a fatal combination of arrogance and paralysis. Instead of recognizing the fundamental shift in consumer behavior and investing heavily in electric R&D or advanced radio control integration, they stubbornly retreated to their most profitable, yet oldest technology. The corporate overseers viewed the .049 Bay-B engine not as a platform to evolve, but as a sacred cash cow to be milked until it was utterly dry. While competitors were pouring millions of dollars into developing better batteries, lighter servos, and frequency-hopping transmitters, Cox's budget for genuine innovation was practically non-existent. Any attempts to dabble in the electric market were half-hearted, underfunded, and usually consisted of slapping the Cox logo on cheap, imported electronic toys that lacked the brand's historical pedigree. They remained fundamentally anchored to the concept of tethered, gas-powered flight, a hobby that felt increasingly primitive in an era of wireless control and digital graphics. The consequences of this conservative paralysis played out brutally in the retail aisles. For decades, Cox Models had commanded massive, prime real estate in hobby shops and department stores. Their bright, cohesive packaging dominated entire walls. But as the 1980s progressed, that footprint shrank with terrifying speed. Store managers, reacting to the demands of the market, pushed the dusty boxes of nitroplanes to the bottom shelves, replacing eye-level displays with brightly lit Nintendo kiosks and stacks of electric RC car kits. Cox Models was no longer the undisputed king of American youth culture. It was becoming a nostalgic novelty. The company was losing the battle for the minds of children, failing to realize that the youth of America no longer wanted to be mechanics covered in castor oil. Yet even as they lost ground to the digital enemy indoors, an entirely different, equally devastating threat was quietly organizing against them in the very outdoor spaces they had once conquered. While the corporate executives at Leisure Dynamics were busy disassembling the mechanical integrity of the engines to appease Wall Street, and while video games were capturing the minds of a new indoor generation, an entirely different structural threat was reshaping the American landscape itself. The physical environment that had nurtured Cox Models, the sprawling, open suburban canvas of the 1950s and 1960s, was quietly vanishing. The golden era of tethered model aviation was entirely dependent on a specific type of geography. Post-war America was defined by an abundance of space. Massive backyards, sprawling empty lots, newly paved cul-de-sacs, and vast unregulated public parks served as the perfect launch pads. For decades, these wide-open spaces provided the necessary clearance to swing a plastic airplane on a 30-foot Dacron line without the fear of striking a power line, a neighbor's fence, or an innocent bystander. But as the decades progressed, the demographics and the architecture of the American dream evolved. Population swelled and urban sprawl pushed outward, paradoxically making the suburbs themselves significantly denser. The empty sandlots were paved over and replaced by condominiums, strip malls, and tightly packed housing developments. The physical distance between front doors shrank dramatically. The expansive, communal feel of the early suburbs was replaced by a rigid prioritization of privacy and property lines. In this newly compacted environment, the defining characteristic of a Cox product, its ferociously loud, high-pitched scream, transformed from a badge of honor into a critical liability. A Babe B 049 engine running at full throttle, turning 15,000 revolutions per minute, generated an astonishing amount of acoustic energy. It produced sharp, penetrating frequencies that could easily pierce through double-pane glass, interrupt a Sunday afternoon barbecue 3 houses down, and rattle the nerves of an entire neighborhood block. What the previous generation had celebrated as the triumphant sound of youthful ambition and mechanical ingenuity, the new densely packed generation perceived as an intolerable public nuisance. The late 1970s and 1980s ushered in a new era of civic regulation. As communities grew closer together, local governments sought to maintain order and peace through legislation. City councils across the nation began drafting and enforcing strict municipal noise ordinances. They established rigid decibel limits for residential zones, effectively outlawing the operation of anything that shattered the weekend tranquility. Public parks, which had once been the ultimate staging grounds for control line dogfights and impromptu air shows, quickly became restricted zones. Across the country, metal signs began appearing bolted to the entrances of municipal green spaces, bearing explicit new rules. No motorized vehicles. No gas-powered models. Quiet zone. The cultural shift was absolute. In the 1960s, a teenager firing up a Cox PT-19 on a Saturday morning would draw a crowd of fascinated neighborhood kids. By the late 1980s, that same action was an open invitation for a noise complaint, angry shouting across a property line, and a prompt visit from local law enforcement. This legislative and cultural shift created a fatal, insurmountable bottleneck for the product. Even if a child managed to resist the hypnotic pull of a Nintendo console, and even if they still possessed the patience to master the increasingly frustrating starting procedure of a compromised engine, they simply had nowhere left to fly it safely and legally. To operate a Cox plane required a perfectly flat, paved surface or a closely mown circle of grass with a radius of at least 30 to 40 feet, completely clear of obstructions and complaining neighbors. In the modernized, heavily regulated American suburb, this specific type of real estate was effectively extinct. This spatial strangulation had a profound unintended consequence. It forced the hobby of fuel-powered model aviation out of the neighborhoods and into exile. Serious modelers were required to migrate to remote, dedicated, and club-sanctioned airfields, often located miles outside of city limits. But the foundational genius of Cox Models had always been its supreme accessibility. It was fundamentally designed to be a backyard hobby, a spontaneous activity that required nothing more than stepping out the back door. The moment that flying a plastic airplane required a dedicated weekend trip, club membership fees, and a lengthy drive to a specialized facility, it ceased to be a mass-market toy. The logistical friction of the experience simply became too high for the average consumer. The internal combustion engine had lost its natural habitat. The silence of the modern suburb was deafening for Cox Models. The company was being squeezed out of existence, not just by myopic corporate management and shiny digital competitors, but by the very evolution of American domestic life. The physical space required to dream out loud had been zoned, paved, and legislated out of existence, leaving the screaming engines with nowhere left to run. As the 1990s dawned, Cox Models was a shadow of its former self, battered by corporate mismanagement and suffocated by a changing cultural landscape. The brand had been traded like a depreciating commodity, eventually landing in the portfolio of Estes Industries in 1996. On the surface, it seemed like a natural pairing. Estes was a titan of the hobby industry, globally renowned for their model rocketry. However, a closer examination of their respective manufacturing DNA revealed a fundamental, ultimately fatal, incompatibility. Estes built their empire on cardboard tubes, lightweight balsa wood, and injection-molded plastics. Their expertise lay in producing inexpensive, single-use, solid propellant rocket engines. They were masters of high-volume, low-cost manufacturing, Cox Models, despite the compromises forced upon it in recent years, was still fundamentally a metalworking enterprise. It required heavy machinery, cutting fluids, precision micrometers, and an intricate understanding of internal combustion. When the executives at Estes looked at the legendary Santa Ana facility, they did not see a temple of American microengineering. They saw an archaic, terrifyingly expensive liability. The sprawling California plant, sitting on increasingly valuable real estate, was burdened by high state taxes, stringent environmental regulations, and the lingering overhead of its massive automatic screw machines. In the eyes of the Estes accountants, there was absolutely no financial justification for keeping the operation alive in its current state. The ruthless logic of corporate consolidation demanded a swift and decisive amputation. The decree was handed down. Cox Models would abandon California. The entire manufacturing operation was to be uprooted and absorbed into the Estes headquarters in Penrose, Colorado. This decision was the death knell for the soul of the company. Relocating a factory of that specific nature is not simply a matter of loading equipment onto flatbed trucks. The true value of the Santa Ana plant did not lie in the iron and steel of its machines, but in the calloused hands and deep institutional knowledge of its workforce. These were veteran American machinists who had spent decades calibrating lathes to 10,000ths of an inch. They possessed an intuitive understanding of how the metal behaved, a tactile wisdom passed down from the era of Leroy Cox himself. When the closure was announced, these craftsmen were not invited to make the journey to the high deserts of Colorado. They were handed severance packages and shown the door. As they walked out of the facility for the last time, the collective memory of how to build a perfect miniature engine walked out with them. The deafening, rhythmic heartbeat of the automatic screw machines, a sound that had defined the neighborhood for a generation, spun down to a halt. The massive vats of cutting oil were drained, the heavily stained concrete floors were swept clean, and the heavy doors were padlocked. The move to Colorado was not a relocation, it was a decapitation. The equipment that did make the journey was integrated into a completely alien manufacturing ecosystem. Without the original engineers to oversee the intricate calibration of the metalwork, the production process was immediately thrown into chaos. The new operators in Penrose, accustomed to the forgiving tolerances of plastic and cardboard, were entirely ill-equipped to manage the demanding physics of screaming nitro engines. The stage was set for a catastrophic collapse in quality, one that would finally break the enduring patience of the brand's most loyal defenders. The reality on the Penrose production floor quickly became a nightmare of microscopic proportions. The heavy imported automatic screw machines from California were successfully bolted to the Colorado concrete, but without the veteran machinists to tune them, they behaved like wild, untamed beasts. The new operators, accustomed to the forgiving nature of cardboard rocketry tubes and injection-molded nose cones, simply did not possess the tactile intuition required for high-performance internal combustion. In the world of the .049 Babe B, a deviation of a single thousandth of an inch, a measurement completely invisible to the naked eye, was catastrophic. It meant a piston would drag against the cylinder wall, generating excessive heat and friction until the engine seized. Or conversely, it meant the seal was too loose, resulting in a total loss of the compression necessary to ignite the nitro fuel. Almost immediately, the scrap rates in the Colorado facility skyrocketed. Bins filled with thousands of defective, out-of-spec aluminum components that were completely useless. Faced with hemorrhaging production costs and a startling drop in yield, the corporate leadership at Estes made another fatal calculation. To offset the losses from the struggling engine line, they aggressively slashed the budget for everything else in the box. The legendary durability of the Cox airframes was sacrificed on the altar of cost reduction. The resilient, high-impact plastics that had allowed the original PT-19s to survive repeated, violent nosedives into suburban pavement were replaced with brittle, inferior polymers, often outsourced to the lowest foreign bidder. The delicate control lines were swapped for cheaper string. The packaging, once a vibrant, sturdy showcase of American manufacturing pride, became flimsy and uninspired. The entire product felt hollowed out, a cheap imitation of its former glory. The true devastation of this downward spiral, however, was not felt in the boardrooms or on the factory floor, but in the driveways and parks of America. By the late 1990s, the children who had grown up in the golden era of Cox Models were now fathers themselves. Driven by a deep sense of nostalgia, they walked into hobby shops or browsed catalogs, eager to purchase a Cox airplane and pass that visceral, mechanical rite of passage down to their own sons and daughters. They would bring the brightly colored box home, mix the pungent nitro fuel, and attach the glow plug battery, fully expecting the familiar, deafening scream that had defined their own youth. Instead, they were met with crushing frustration. Fathers and children would spend hours under the hot sun, endlessly flipping plastic propellers that snapped under the pressure. The compromised reed valves failed to draw fuel. The poorly machined pistons leaked compression with a pathetic hiss. If an engine did miraculously sputter to life, the violent vibration would often tear the cheap, brittle plastic airframe apart before the plane even completed a single lap. The nostalgic bridge between generations was completely shattered. The experience no longer taught patience and physics, it only taught disappointment. Word spread rapidly through the tight-knit modeling community. Hobby shop owners, who had once been the fiercest advocates and most loyal distributors of the brand, stopped recommending Cox products. They could not afford the soaring return rates or the anger of frustrated customers. The remaining inventory began to gather dust on the bottom shelves, ignored in favor of reliable imported electric RC cars or high-quality Japanese nitro engines. A reputation for absolute reliability, meticulously built over 4 decades by Leroy Cox, was entirely dismantled in less than 5 years. The brand equity was completely spent. Cox Models had not just lost its market share, it had lost its soul, and the market was finally, definitively turning its back. As the new millennium broke, the American hobby industry underwent a radical, final paradigm shift. The global supply chain had matured, and the manufacturing epicenter for consumer toys and recreational electronics firmly relocated across the Pacific. In the early 2000s, a tidal wave of cheap, highly advanced and mass-produced hobby products from China flooded the American market. For a weakened, geographically displaced, and technologically stagnant brand like Cox Models, this was not just a competitive challenge. It was an extinction-level event. The nature of model aviation had been completely rewritten by 2 massive technological leaps: lithium polymer, LiPo batteries, and brushless electric motors. Together, they provided an astonishing power-to-weight ratio that finally surpassed the capabilities of miniature internal combustion engines. Chinese manufacturers combined this advanced electronics package with lightweight, crash-resistant foam airframes to create a new category of product: the ready-to-fly RTF electric airplane. These modern kits were a revelation of convenience. A child could pull a foam P-51 Mustang out of a box, plug it into a wall charger for an hour, and immediately launch it into the sky using a sophisticated, interference-free digital radio transmitter. There was no messy nitro fuel, no burned fingers, no deafening noise to anger the neighbors, and, crucially, no prerequisite knowledge of mechanical engineering required. They flew silently, beautifully, and reliably. And because they were manufactured overseas, utilizing inexpensive labor and heavily subsidized supply chains, they retailed for a fraction of what it cost to produce a temperamental, gas-powered model in the United States. Against this relentless, silent, and incredibly cheap armada, Cox Models was hopelessly outgunned. The brand had effectively become a corporate zombie within the Estes Industries portfolio. It was nominally alive, but completely devoid of its original animating spirit. The production reality inside the Colorado facility was a grim portrait of industrial decline. There were no more continuous, roaring assembly lines running multiple shifts. The manufacturing of the iconic .49 engines had been reduced to a sporadic start-and-stop operation. A small handful of workers functioning in a quiet, neglected corner of the sprawling Estes plant would occasionally assemble batches of engines using whatever usable components they could scavenge from the aging, increasingly worn-out molds and dies. The product that actually made it into the box was a tragic shadow of Leroy Cox's original vision. To compete with the aggressive pricing of imported electric toys, the corporate accountants continued to strip away every last vestige of quality. The once proud, brightly colored display boxes that had dominated hobby shop walls were replaced by cheap, transparent plastic blister packs designed to hang on the pegboards of discount department stores. The engines themselves, constructed from inferior alloys and assembled without the rigorous testing protocols of the past, were now widely regarded within the modeling community as disposable novelties rather than precision instruments. Sales figures, which had been steadily declining for a decade, went into an uncontrollable freefall. The modern youth demographic was entirely captivated by video games, the internet, and plug-and-play electronics. They had zero interest in smelling like exhaust or learning the dark art of tuning a carburetor. The older generation, the fathers and grandfathers who might have purchased a Cox model purely out of nostalgia, had already been burned by the abysmal quality control of the late 1990s. They simply stopped buying. The target audience for a loud, messy, tethered plastic airplane had effectively shrunk to zero. For the executives managing the ledger, the Cox division was hemorrhaging cash with every passing quarter. They attempted half-hearted measures to resuscitate the brand, briefly experimenting with sourcing their own cheap electric models from overseas and slapping the classic Cox logo on the wings. But it was far too little, far too late. The market saw through the cynical branding exercise. Cox was an internal combustion company. Their name meant nothing in the realm of silicon and lithium. By the mid-2000s, the atmosphere surrounding the brand was one of suffocating inevitability. There were no more marketing campaigns, no new product development meetings, and no grand strategies for a triumphant return. The holding company was simply waiting for the existing inventory of parts to be depleted, unwilling to invest a single additional dollar into repairing the aging tooling or buying fresh aluminum. Cox Models was bleeding out on the corporate floor. The engines that had once powered the imaginations of millions of future engineers were now reduced to clearance bin afterthoughts, quietly gathering dust while the world flew past them on silent, battery-powered wings. It was no longer a question of if the empire would fall, but merely a question of which Tuesday the accountants would finally decide to pull the plug. The inevitable execution order from the corporate holding companies finally arrived, but it did not come in the form of a dramatic public announcement or a spectacular bankruptcy. It was a quiet, bureaucratic offloading, in a last-ditch effort to extract a few final dollars from the decaying corpse of the brand. Estes Industries sold the remaining Cox tooling, unsold inventory, and the historic trademark itself to a private buyer. For a brief, fleeting moment, there was a glimmer of hope among the die-hard hobbyist community. This transition meant the remnants of the Cox empire were making a somber, final pilgrimage back to their birthplace, Southern California. The ultimate resting place of the legendary model company was not a sprawling, state-of-the-art manufacturing cathedral like the original Santa Ana plant of the 1960s. It was a modest, nondescript warehouse situated in a quiet industrial park in Corona, California. Here, a skeleton crew of dedicated enthusiasts and private investors attempted the impossible, a mechanical resurrection. When the heavy shipping containers from Colorado were unsealed, the true extent of the corporate devastation was laid bare under the harsh, fluorescent lights. The new team carefully unpacked the massive steel molds, the casting dies, and the remaining extrusion equipment that had once formed the beating heart of American miniature aviation. To the trained eye of a machinist, the sight was profoundly heartbreaking. The tooling was heavily scarred, warped by years of improper use by untrained operators, and fundamentally exhausted. The microscopic tolerances that Leroy Cox had so fiercely protected were completely gone, replaced by the sloppy, worn-out realities of decades of corporate neglect and cost-cutting. Despite the insurmountable odds, the small team in Corona tried desperately to breathe life back into the iconic Aero 49 engine. They painstakingly set up the few functioning machines, lubricated the dry gears, and attempted to produce small, artisanal batches of engines. Their strategy was to abandon the mass market entirely and cater strictly to the nostalgic collector's market, the fathers and grandfathers who remembered the golden days. But the physics of the damaged metal refused to cooperate. The tired, degraded molds could no longer cast engine blocks that held adequate compression. The pistons dragged against uneven cylinder walls. The reject rate on the Corona assembly tables was astronomically high, making every single engine produce a massive financial loss. It was a valiant, emotionally driven effort by people who genuinely loved the brand, but they were fighting a war that had been decisively lost a decade earlier. Outside the walls of the Corona warehouse, the world had entirely moved on. The skies over local parks were now silently dominated by cheap, imported electric drones and foam-ready-to-fly airplanes. The harsh, intoxicating scream of a nitro-fueled engine was no longer a symbol of childhood wonder. It was a museum piece, an anachronism from a forgotten century. The financial reality of the Corona operation quickly became undeniable. Selling a handful of hand-assembled, compromised engines to a rapidly shrinking pool of aging collectors could not sustain the cost of Southern California real estate, let alone generate the millions of dollars required to remachine the destroyed tooling from scratch. The final custodians of the Cox legacy found themselves staring at a harsh truth. You cannot reverse time. The dream of a revival was dead, leaving only one excruciating task left to perform. February 2009 arrived not with a bang, but with a quiet, hollow resignation. The decision was finally made. There would be no more desperate attempts at revival, no more late-night tinkering with exhausted machinery, and no last-minute corporate saviors swooping in with a sudden influx of capital. The bank accounts had run completely dry, and the grim, undeniable calculus of liquidation took absolute precedence over nostalgia. The small Corona facility, the final desperate outpost of the once mighty Cox Models empire, prepared for its permanent closure. The subsequent dismantling of the factory floor was a brutal, unsentimental affair, devoid of any reverence for the history it contained. The massive steel molds and intricate casting dies, the exact tooling that had stamped out tens of millions of Baby B engines and PT-19 fuselages, the very artifacts of Leroy Cox's uncompromising mechanical genius, were not carefully cataloged and preserved for a museum of American industry. Instead, they were hoisted roughly onto the forks of industrial loaders, weighed on heavy-duty scales, and unceremoniously sold to liquidators as bulk scrap metal. It was the ultimate indignity for a company founded on microscopic tolerances. Decades of brilliant micro-engineering history, representing millions of dollars in original research, development, and American labor, were reduced to a crude price-per-pound commodity. The very tools that had forged the childhoods of countless aerospace engineers were destined to be hauled away to a foundry, melted down into unrecognizable slag, and repurposed into mundane commercial goods. The rest of the facility was systematically stripped of its identity. Bins containing the last remaining inventory of tiny aluminum pistons, precision machine cylinders, and brittle plastic propellers, the scattered, unassembled heartbeat of the brand, were auctioned off to surplus buyers for pennies on the dollar, or simply swept into massive industrial dumpsters. The distinct, sharp aroma of castor oil and cutting fluid, a scent that had permeated the lives of thousands of workers over more than half a century, was aggressively scrubbed away. It was replaced by the sterile, cold smell of chemical cleaning agents and vast, echoing empty space. For the final handful of workers who had stayed until the bitter end, attempting to keep the dream on life support, the last day was a surreal and deeply quiet experience. These were people who understood the profound magic of internal combustion, who knew exactly what those engines had once meant to the world. As they packed their personal micrometers and wrenches into battered metal toolboxes, there were no television cameras, no press conferences, and no public acknowledgments of the monumental loss taking place. The world outside the corrugated roll-up doors of the warehouse remained completely indifferent to the death of a titan, distracted by the glowing screens of a digital age. When the last pallet of scrap was loaded onto a flatbed truck, the heavy warehouse doors were rolled down and the final padlock was snapped shut. In that instant, an era officially concluded. The Cox Models name, which had once been a ubiquitous, roaring fixture of American boyhood, a brand that commanded entire aisles in department stores across the globe, was reduced to nothing more than a dormant trademark buried in a holding company's legal filing. The deafening 15,000 RPM symphony that had defined the optimism of the post-war suburbs was finally and permanently silenced. The machine had completely stopped. Today, if you visit the site of the original Santa Ana factory, You will find no historical plaque commemorating the millions of engines that were born there. The air no longer smells of nitro fuel, and the deafening roar of the testing booths has long been replaced by the quiet, anonymous hum of generic office parks and commercial real estate. The physical empire that Leroy Cox built from a humble post-war garage has been entirely erased from the map. But the true legacy of Cox Models was never the aluminum, the plastic, or the brick-and-mortar buildings. The legacy lives on in the minds and the calloused hands of the people it shaped. Across the United States, and indeed around the world, there is an entire generation of men and women who look up at commercial airliners, military jets, and spacecraft with a deeper, intuitive understanding of how they work, simply because they spent their childhoods kneeling on suburban driveways, coaxing a .49 Babe-B engine to life. Countless aerospace engineers, mechanics, and commercial pilots trace their foundational spark, their initial consuming fascination with thrust, lift, and thermodynamics, directly back to a brightly colored PT-19 control line airplane. Cox Models provided a visceral, unfiltered education that no textbook and certainly no video game could ever replicate. It taught patience, problem solving, and the unforgiving reality of mechanical physics. When a child operated a Cox model, they learned that actions had immediate physical consequences. If the needle valve was too lean, the engine starved and died. If the control lines went slack, gravity won and the plane crashed. It was an era that forced young minds to engage directly with the material world, to learn how to fix what was broken, and to intimately understand the inner workings of the machines that propelled modern society forward. The tragic slow-motion collapse of the company is ultimately more than just a grim case study in corporate mismanagement, changing consumer habits, or the unavoidable decline of domestic manufacturing. It represents the quiet passing of a distinctly hands-on era. We have traded the messy, loud, and intellectually demanding reality of miniature internal combustion for the sterile, frictionless convenience of the digital screen. The heavy machinery has been scrapped, the nitro fuel has dried up, and the American suburbs have gone silent. Yet for those who were there, those who remember the sweet smell of burnt castor oil and the stinging cut of a rapidly spinning nylon propeller, the echo of that high-pitched scream remains. It is the lingering soundtrack of a time when the sky was not just something to be passively observed, but something to be conquered, one tiny, roaring engine at a time. The story of Cox Models is, on the surface, a painfully familiar tragedy of American manufacturing. It is a cautionary tale of a visionary founder stepping away, only to watch his life's work be systematically dismantled by a succession of corporate holding companies. These distant boardrooms consistently prioritize short-term quarterly margins over metallurgical integrity, hollowing out the product until the loyal consumer base simply refused to accept the compromise. But to view the death of Cox Models purely as a business failure is to miss the profound cultural void it left behind. Leroy M. Cox did not just build miniature internal combustion engines, he built the crucial first step on the ladder of American aerospace dominance. For over 40 years, his screaming .049 Babe-B engines served as the ultimate unforgiving teachers of physics, aerodynamics, and mechanical resilience. Today, we live in an era completely defined by the digital screen. The modern generation learns primarily through virtual simulations, swiping glass interfaces that offer zero tactile resistance and demand zero physical consequence. If a virtual airplane crashes, a digital reset button instantly erases the mistake. But in the physical, oil-stained world of Cox Models, a crash had weight. It meant walking to the local hobby shop, buying replacement parts with saved allowance money, and spending hours at a workbench learning exactly how to fix the broken machine with your own hands. It fostered a gritty resilience and a deep intuitive mechanical wisdom that is becoming dangerously rare in the modern age. The silence that now blankets the American suburbs, where the sharp, deafening roar of tethered model airplanes has been entirely replaced by the quiet, frictionless whir of disposable electronics, is profound. We undoubtedly gained clean, effortless convenience, but we lost a visceral rite of passage. The Cox Models empire may have been sold for scrap, its million-dollar molds melted down, and its legendary factories paved over. But the spirit of what it represented cannot be erased by a spreadsheet. It endures in the mind of every engineer, pilot, and mechanic who first learned to conquer gravity and tame fire in their own backyard. Thank you for joining us on this journey through the rise and fall of a mechanical legend. If you grew up with the unmistakable sound of a Cox engine, or if you found this piece of industrial history compelling, please leave a comment below. We would love to read your stories. Don't forget to subscribe to the channel for more documentaries exploring the forgotten factories, empires, and systems that build our modern world.